Building a modern AI application involves weaving together model reasoning, external tools, and human oversight to complete a complex task. Historically, developers relied on a centralized Python controller, a rigid orchestrator that dictates exactly when the model speaks, when the tool runs, and when a human is prompted. This hand-wired approach is brittle. Any change or addition of a new agent typically requires a total rewrite of the control loop. As models grow more capable, the primary bottleneck shifts toward the structural burden of maintaining this centralized orchestration. AutoGen assumes a different architectural stance. Developers should avoid writing an external orchestration script entirely. This framework employs a concept called conversation programming. Here, both the computation and the control flow are driven by the exchange of messages between agents. The conversation serves a dual role. It carries the data within the messages while simultaneously acting as the control signal that determines the next actor. Shifting control flow into the conversation changes the design process from scripting rigid logic to programming how independent agents reply to one another. The framework is built on the conversable agent, a foundational object designed to replace isolated, single-purpose agents. Each agent can be configured with 3 backend capabilities: LLM reasoning, human input solicitation, and code or tool execution. Because these capabilities are composable, developers can configure the exact mix required for a specific role without building bespoke agents from scratch. AutoGen includes pre-configured subclasses for standard tasks, the assistant agent for LLM-backed reasoning, and the user proxy agent for handling code execution and human feedback. This composable architecture allows a small set of base agents to adapt to a massive variety of complex workflows. If there is no external controller, the agent must have an internal mechanism to decide its next action the moment a message arrives. That mechanism is the generate reply dispatch. A message triggers a scan through an internal list of reply functions. It evaluates custom functions first, then defaults for LLMs, humans, and code. The first function returning a value wins, halting the chain and preempting subsequent behaviors. Registering and ordering these functions defines the agent's behavior. This programming surface removes the requirement for a separate orchestration layer. Once a reply is generated, the agent automatically sends it back to the sender. This auto-reply mechanism turns a single message into a multi-turn loop. In a code execution loop, the assistant proposes Python code, and the proxy runs it. If the code fails due to a missing package, the proxy feeds the error back, and the assistant automatically corrects and resubmits the code. Unchecked autonomous loops can lead to infinite conversations, creating the need for precise stopping conditions. AutoGen manages this through layered termination. Developers can set limits, like a reply cap, or instruct the model to generate the token terminate when done. Emergent reply chains and termination gates allow autonomous loops to run safely. For pairwise interactions, external orchestration is unnecessary. Workflows involving a coder, a reviewer, and a planner require complex interaction dynamics that go beyond simple back-and-forth messaging. For these dynamic group topologies, the framework provides a group chat manager. The manager follows a 3-step cycle. It selects the next speaker using an LLM roleplay prompt, collects the response, and broadcasts that message to the shared context of the entire group. This introduces an architectural trade-off. To manage dynamic, nonlinear routing, AutoGen reintroduces a pluggable controller in the form of this manager. While pairwise interactions remain controller-free, the framework trades that purity for the routing flexibility needed to scale to large agent groups. The framework's efficacy is visible across diverse applications, ranging from math problem-solving to embodied instruction following. On the math dataset, a multi-agent AutoGen setup reached 69.48% accuracy, compared to 55.18% for a vanilla GPT-4 baseline. This gap includes a significant variable. The baseline GPT-4 cannot execute code, while AutoGen relies on a tool execution loop to correct its reasoning. This gap demonstrates the efficiency of tool access and iterative error correction, rather than a definitive advantage in pure multi-agent reasoning. There are operational costs to consider. The original research does not report token cost multipliers or latency tracking for these autonomous multi-turn loops. Developers must weigh the increased token usage against the reduced engineering time provided by composable agents. The core shift is structural. Developers no longer handwrite rigid orchestration paths, they define conversational rules. AutoGen moves multi-agent control flow from external Python scripts into the conversation itself, treating it as an emergent property of agent interaction.